Okay, so now we're going to look at how we can use a massing diagram, carry that massing diagram into the project environment, and then we can generate data from that, right? Now, if you remember our last conversation, we spoke about the importance of doing a digital massing model, right? So you would have maybe a physical massing model, you would have maybe sketches of your mass, but then it's also important to create a digital massing model. And from that digital massing model, there are different things that you can get, some of which solar study. You can start to develop your facade. You can use it for site analysis. All of this information you can generate just using the massing model before going into the full production of doing walls and windows and so forth. So what we're going to look at now is how can we take the massing model that we did last time, and from that massing model use it to generate, in this example, a solar study. Now this is what our massing model looked like, and also remember that this was basically a rough sketch. We actually created this massing model using sketches and diagram which are representative of the architectural design process. So this is what we use to generate the massing diagram. Now what we need to do now is to take this diagram, which is a relatively scaled diagram. We need to put it in the actual location that this building would be in, and then from then we can start to look at some information that we can get from it. Now one of the important things to note is when we had created this massing model, right? If you remember, we went to new and we created a conceptual mass. Now the conceptual mass is really made from what Revit refers to as masses, and a mass is kind of like a shadow figure. It doesn't really exist as a type of wall or window or 3D object, and we're going to see that happen when we actually take this from our family conceptual mass editing environment and put it into the project environment. We're going to notice that the model is going to come in as a kind of a shadow representation, and that is perfectly normal, and we will look why that is so whenever we create a conceptual mass. Okay, so before we can get things going, we need to now create a new project, and to do that we're going to go to File and we're going to choose New Project. Now if you recall from our previous presentation, remember Revit has two environments, a project modeling environment and a family modeling environment. Now the family modeling environment was further divided into these other subcategories, and we created a conceptual mass. So now we're going to be using the project modeling environment to actually create our building model. So to do that, we're going to go to File and we're going to go to New and Project, or we can just click New. When you click New, it will default to Project, and we are going to use the architectural template, and we're going to choose OK. All right, great. So now you can see I have a brand new project open, right? You can also see that I still have the conceptual mass open, and we're not going to need that, so we're actually just going to close that out. Now actually the first thing you want to do when you're starting a new project in Revit is to set up your project information and your location data, right? Your project must exist somewhere, and the way how Revit intends for you to use it is for you to plug in that data so you can generate accurate simulations if you so choose to do so, which we are going to do a solar simulation. So first thing we're going to do is we're going to go over to manage, and we are going to go over to project information here. Now in project information, we want to enter things about the project. Now this is a major project and it's a school project, so maybe the organization could be maybe CSA. The description could maybe be major project, right? The building name, it's the M plus pavilion, right? And the author for this particular document, it could be the name of the student. So in this case, I will put Brian Williams. All right. And there's some other information that we could put here, project number and that kind of stuff, but we don't really need to drop that information in. But this information is important here, so we're going to choose OK on that. Next, we're still under the Manage tab, which deals with the management of your project. We want to change our units, and right now the default is imperial, so we want to change the length to meters and maybe use an M symbol, carry it to 2 decimal places, and choose OK. And maybe for slopes, let us use degrees and use that as a symbol. And I think everything else, for area, we can change that to square meters. There we go. And probably put that to 2 decimal places. All right. So now we have set up the project, the units for our project. Okay, now the next thing we want to do is to set up our location, which this part is going to be super important, especially the fact that we're going to generate a solar study. So we're going to choose location, and it's going to allow us to actually browse on a world map. And what you will see is it will have the location, and it will show you a map here, and it's going to default to maybe an address in the US by random. And what we're going to do is input the actual address here, right? So let's look that up. So if I head on over to Google Maps and I type M plus pavilion, it shows me the location of that, and it also shows me the address that's located in Hong Kong. So what we're going to do is copy this address here, and we're just going to stick that here and choose search, and this should give us that location there. Now the other thing that you might want to do, just to make this a little more accurate, is, and let's just get this Google on this side. And with the map on this side, we can kind of see where it's located, which is here. You can see it there. And what we want to do is just match that with the maps on this side here. So according to this map, it is somewhere on this side, right below where these roads go underground. So somewhere right about here, and it's located somewhere in this region. So what we're going to do is actually drag this home button and just put it somewhere here. Now, it doesn't have to be like 100% accurate, but you know, you just want to get it in the right location. Let's put it about right here, right in the right location, so we can get, you know, as accurate values as we can. And we're going to choose OK there. All right, let's minimize this. All right, so now we have our location set up. Now the next thing we're going to do is to input our surveyor points, right? And this is a important step in the process, because you would get survey information from the surveyor or from the surveying documents. And to make sure that we're all operating on the same geographically correct information, we want to input those values directly. So if you take a look on the class files, you will see a site plan that you might see here. And if I make this just a bit bigger, you can see the orientation of the site. You can see where the building will go. And then you can see the site boundaries that's here. Now for each of these site boundaries, it actually has the exact longitudinal, latitudinal values and angles, which you can input directly in the program, and it will give us the exact drawing here. Now it's important that we input these values and we don't carry this site plan into Revit and trace it, because this is a image, and you know we will never be able to trace this 100% if we try to visually trace a line here. So instead, what we should do is input this data manually. And this is the same process if you were getting information from a surveyor. You would want to make sure that either you get the direct surveyor drawings that has a site plan on it, or you get the longitudinal values that you can insert in the program to ensure that your site that you're designing on is geologically correct. So in this case, we're going to insert these values directly into Revit, and that will give us an accurate representation of the site. So we're going to put this to one side here, and while there, I'm going to go to the site level. There we go. And you can see that Revit in the architectural template has a center position that you see here, and it also has these arrows are really views. Now we might know what most of these things are because we have used Revit before, right? So this is your project center that is right here. So this is an important point here. And what we're going to do is we're going to go to Massing and Site, and then we see where we have the property lines. Now when you click the property lines button, you will notice you will get a message that says, do you want to draw the property lines by entering distances and bearings, or do you want to do it by sketching? So let me reiterate. The process that we're going to use is going to be actually both, but it is important that the first thing we do is enter the values by entering the bearings first, right? And again, we don't want to use sketching and try and sketch from a image, because it will not be 100% accurate. All right, so we're going to use enter by distances and bearings. We're going to get this table here, and essentially what we want to do is insert these values in this table, right? And these values will give us the exact accurate positioning that is actually based on the survey that would have taken place on the site, and is data coming directly from the surveying instruments, right? So you're just translating that digital data, keeping it 100% precise to what the instruments recorded. All right, so this is just a direct translation. So so we have distance, that's going to be 39.33. Remember, we changed our units to metric, so we should be on the same page. Okay, that is going north, and the angle here is 40. There we go. East, and it's a line, and we're going to just repeat the same thing. We're going to go to insert, and we're going to go this way. So the next one is the length is going to be 35.1. The bearing is 50, and it's going southeast. There we go. And next we're going to go to 10.36. The bearing is southwest. And the angle is 40. We're going to go again. Okay, then we're going to go to the next one, which is 18.65 with a bearing of 0, going south, southwest. Next we go to 22.83 with a bearing of north, a bearing of 90 degrees. There we go. We got 2 decimal points in there. Right, going northwest at 90. And 29.60 going northwest and bearing of 50. All right, and we are back to the beginning where we started from. So all right, and with that we're going to click OK, and you will see that it gives us our site here, and this site is actually accurate according to bearings and distances. Now we can put this anywhere, so we're just gonna drop it right there. These points here, these views, they can be moved, so we don't have to worry about them just yet. Okay, so now we have that done. Now the next thing we actually need to do is we are gonna trace this line here using the model line tool. Now you might wonder, why are we going to be tracing this line? And this really has to do with I guess you could call it maybe a glitch with Revit. We are going to now go into how we set up our project north and true north. And what happened is that when you start to make those settings, they start to mess around with the bearings that we have placed for our points here. So in order to circumvent that issue, what we do, let's go over to model line. We're just going to trace this with the model line, and we're just going to use the pick lines feature. There we go. So now we have a model line version. Now, for now, we can get rid of the property line version. We are going to come back to it, but to allow us to set up our project north with ease, it's going to be incompatible with the property lines feature. So we're going to get rid of that, but we don't have to worry because this is pretty accurate, the model line, because we use the exact points that we got from the bearings. All right. However, we were unable to use the bearings feature with the model line. So that's why we had to start it off using the property lines feature, which would allow us to generate the shape from bearings. Now, what we're going to do next, we're actually going to put this this site into our model, and to place this image on our site, we're going to use the insert feature. So we're going to go to insert image, and we have a little browser that comes up. So we're now going to look for the image, and I have mine in this folder, and here it is. All right, and it's going to ask us to place the image. So there we go. Now we have our image on our site, and what we're going to do is, just for reference purposes, we are going to scale this image to match this property line that we have here, because we know that this property line is pretty much accurate, right? Because we generated it from bearings. Now, if the image doesn't quite line up, then that's okay, because we're only using the image as a reference, but all our dimensions and line work is going to come from the actual property line that we just drew. So we don't have to worry about any inaccuracies that we might have. All right. Now I'm just going to scale this. I can just scale it manually, actually, because it's pretty close. One way that you can scale it, for example, rather than trying to guesstimate, you know, do I need to make this the image bigger or smaller, I can just move it to maybe one corner. So if you can kind of see here, I'm moving the image to one corner there. There we go. And what I'll do is just use the scale tool, and I will say from this point to this point should be as long as really this point. There we go. And that will get us roundabout scaled. Now, as I said, don't worry if it doesn't line up exactly. It doesn't really matter, because we are going to be using the actual line work instead of the site image. The site image is just going to be there to give us some references. So, you know, we can insert things like context buildings and all of that, which doesn't have to be have pinpoint accuracy. All right. So now what we're going to do, let's move these points. I'm just going to drag it in the square. And we're going to talk about these later. These will actually generate our elevations, but we're going to move these out of the way here. All right. Now, if you will notice that most of the lines that we're going to be drawing of our building here are going to be at an angle. So for example, if I wanted to draw a line this way, and let's say I went to my wall tool, notice that everything is going to now have to be at an angle, and it's just a bit harder to work like that. It would be much easier to work and design if my footprint were aligned to the X and Y axis. And this is why Revit has a feature called True North and Project North. Now, in this site plan view that I'm in now, this is set to the true north, meaning north is actually up, and our building in comparison to the compass is actually at an angle in real life. So real life is equal to true north. Now, for the purpose of our project, what we want to do is have a project north that will angle our building in the best possible way to make it easier to draw lines and design, right? But we want to establish what is true north definitely first, so that when we generate our solar study, it will be accurate based on where the north is. So in order to set that up from this view here now, notice that where you see orientation on your left, and this is, ensure you don't have anything selected, because if you remember, when you click on a line or an object, Revit will show you the properties for that selected object, right? So we want to click on the actual workspace, and it will show us the properties for that workspace or that floor plan. Now, if we look on the orientation, we will see where we have true north, where we have project north, and we can change that to true north. Now, when you do that, nothing will happen because by default, Revit's true north and project north are the same. But obviously, we don't want that. Our true north is this, but we want our project north, which is we want to angle the building to a way that makes it easier to draw. We want that to be different. Now, to make that work, what we're going to do is we're going to be using the Manage tab, and we're going to be using the Position tab here. Now, in the Position tab, we see where we can rotate our true north. Now, we don't want to rotate our true north because our true north is currently correct, meaning north is up, and this is how the building is oriented. However, let's go to our project north now. Choose apply, and in our project north, we want that now to be at an angle. So we're going to go over to position, and we're going to go to this option that says rotate project north, right? All right. So when we click on that, we're going to get this message, and what this is saying is, do you want to rotate your entire drawing 90-degree clockwise, or do you want to rotate it and align it to a selected line? Now, the reason they put this option here is, if you think about it, if I selected this line here as the line to rotate our entire drawing to, well, now the entire drawing will be rotated to allow this line to be flat. So now this line would then become that line, and then all the other lines will be based off of that. So now my drawing would be rotated that way because I based it off this drawing. Now, Revit will decide whether it should turn it horizontal or vertical, but whichever way it turns it, it is gonna make it flat. So let's test that out actually. So we are going to choose the option to align to a selected line, and we're going to pick a line. Now we can really pick any line, or at least any one of these perpendicular lines here. So I'm going to pick that one. Now notice what Revit did. It rotated our drawing where these lines are perfectly flat, which makes it easier to do our drawing here. Now, usually for architectural drawings, we might want the entrance of the building to be pointed down on the sheet, you know, and also for the purpose of later setting up our sheet and trying to fit multiple drawings on a sheet, we want to turn our true north where the building is going in a portrait position instead of a landscape position. So we're going to go back to position here, and then we're going to go to project north again, and then we're just going to, this time we're going to choose rotate clockwise, and this is what we'll get. Now notice what we'll have now are two types of north. We will have a project north, and then we'll also have a true north. Now when we're drawing lines, we can always switch to project north, and that will make our lines easier to draw because everything is in straight lines. All right. Now let's go back to true north. All right. Now what we're going to do now is actually convert these model line back into our property line, right? Now remember, we already drew the property line, but the reason we changed it to a model line was because REVIT doesn't play nicely when you try to create a project north and a true north. To create a project north from a true north using property lines, they because of the bearings, they get let's just say confused. But when we do that with a model line, it's no problem. So what we'll do now and is just go to our massing and site, and we'll go to a property line. And what we'll do now, we can just create a property line and create it by sketch, because we have these lines were originally generated from the first property line. So we're going to create by sketch, and we're just going to pick line and pick back these lines here and choose OK. And now we have back our property line. So we can actually, I'll just use tab here, and I'll just tab into the model line, or what I can do is let's tab into our model line, and I will just delete those model lines. And you might say, okay, why didn't we use the model line? Why did we have to draw back our property line? And the reason is the property line has certain features that are attached to it that are relatable to the feature of property and setting up your property that a model line doesn't have. So you want to keep your property line as an actual property line. But in our case, we had to use the model line so that we could use the True North and Project North feature. So now if we go to Project North, you can see our property line rotates no problem. However, if you were trying to do that using the original drawn property line, it would not work properly. So that's just a little bug, I would say, in REVIT, and this is how we circumvent that. All right. So now we have this done, it is time to actually import our massing model, and we're going to align our massing model to our site so that we can generate our solar study. Now, on my site level, when I insert this massing model, ideally, anything that I insert in this drawing, I would want to do that while I'm in the Project North, because, you know, as you can see, the Project North allows your drawings to be aligned to the X and Y axis more efficiently. So if I carried in a rectilinear object, it will already be aligned to the building rather than using the True North. And everything I import into this drawing, I would then have to rotate it 40 or 50 degrees, right? So that is a nifty feature. So what I'm going to do now, I'm going to angle this that way. And then I'm going to actually open my massing model file. Okay, so that's our massing model. So I have my massing model and I have my site, right? Now, let's also keep in mind that my massing model is actually a REVIT family file, right? Now, if you remember from our REVIT presentation, the REVIT project modeling environment is a RVT file, and the family modeling environment is a RFA file. So this model that I have here is actually saved as a family file. Now, as we also remember that family files go into project files. So in order to load that into our site file here, you're going to go to the family file, and notice these buttons up here where it says load into project, and then it says load into project and close, right? Which it just means it's going to close the file after it loads it into project. So I'm going to choose load into project and close, and it's going to load it into the only project that's open. Now right away you're going to get this message to say that Revit has enabled a show mask mode, so the newly created mask will be visible. And this is linking back to what I said earlier, that the conceptual mask modeling is really a kind of shadow object that you're supposed to use to help to generate your actual model, right? It's not your actual model. It's just assisted. And which is exactly, when you think about it, that is what a massing model is. A massing model is not your actual project, but it just helps you to know how the proportions of your model will look like. And in most cases, it very well ends up looking much different from the initial massing model, right? So we're going to choose close. Then this is going to ask us to place the model. Now, we can place it anywhere. I'm just going to drop it out here. And notice when we place the model, I'm going to press escape now. When we press the model, when we load the model, you can see that it is loaded perpendicular to our site, because remember we had it in Project North. So let's go back to our site view here, and we can see the massing model that is here actually. And what we're going to do is just move it into place. Now you can see that, oh, this actually needs to be rotated according to the site. So we're going to use our rotate tool and rotate that 90 degrees, which is no problem. Now in our case, we are pretending that our actual model would be generated from this massing model. Think about the architectural process. You don't have your building yet or know what it looks like, but what you create is this massing model, and from this massing model you're going to design your final project. Now of course the M+ pavilion is already built, but let's use our imaginations for a bit. In the design process of creating this pavilion, the original designers might have created a massing model, and from that massing model the design eventually warped into what we have now. So if we didn't know what the final design looked like, this massing model is definitely leading us in that direction. Alright, now if we look at our model in 3D, I'm going to click this 3D icon here, which will generate a 3D view. That is what our massing model looks like. And notice that if I change my view to shaded, let's say, notice that the massing model is kind of a ghosted object. It's not an actual 3D object that exists in our scene. And if you really remember that message that we got at the beginning, when we imported the model, it said it's going to enable the show mass from floors. It's going to enable us the ability to see masses in our project. Now, the idea is that these types of models are not going to be produced. They're not going to be, for example, put on a sheet or directly used, but instead they're used to guide what the final design will look like. So because of this feature, Revit's massing, Revit is really allowing us to use this massing model and turn them into walls and floors that we will later turn into our final project, or maybe we will just do our own walls and floors. So before we can generate a solar study, we have to convert this massing model into an actual model. Now, to do that, what we're actually going to do is we are going to select our massing model here. And then when we go to modify, notice you see this feature where it says mass floors. And what it's going to do is give our massing model the ability to have floors. And these floors will be based on the floor levels that we had created when we were creating the massing model. Now, the reason you want to do this mass floors is because it will allow those floors to be converted to actual geometry floors. Because remember, this is a ghost object. It doesn't really exist. The geometry in this doesn't really exist. It's just like a shadow figure that is just guiding us to create actual geometry. So we're going to use them to show the mass floors, and we're going to tick those and choose OK. Now you can see where it has generated these purple shadowy figures, which really represent where the floor levels will be in our massing model. Now there aren't actual floors just yet, and the walls aren't walls just yet, and the roofs aren't roofs just yet. They are still a kind of shadow guide to our actual model. Now we're going to go back over to massing, and we are going to now create a floor by mass. So we're going to click that now, and notice that we are now able to select these floors. Before we didn't have these floors, but these floors are actually generated based on the levels that we have. So I'm going to click this floor here and that floor there, and now these floors, now I'm going to choose create floor. And now this is actual geometry in our project, right? Now it doesn't mean that this is what the floor levels will actually look like. It will actually look like this. It may change, it may not. And next, what we want to do is we want to turn these walls into, we want to get walls from our mass. So we're going to choose the wall feature here, and what that will allow us to do is to select actual faces, and when you click these faces, they will actually change to walls. Now in my case, I made the mistake to have double walls, and this is why when you're using the conceptual mass mode, you don't have to worry about the thickness of walls, because these will eventually be converted to walls anyway. So there we go. All right. Oops, there's another one here, and let's put another one here. And then lastly, we can go to roofs, and we'll put a roof there. All right. So now that we have actually, we need to choose the create roof feature. And now we have actually created geometry that will be used in our model. Now, if I go back to massing and floor, I can click this object here and notice that that shadowy figure is now gone, because we have generated from that shadowy figure actual geometry. Now, in some cases, as I said, this will eventually turn into your final model. However, in our case, we are going to use it to generate a solar study. This may not necessarily be our final model, but it allows us to study the model. Now, to generate the solar study, what we need to do is first enable our shadows. Then we need to enable the sun path. We're going to use the specified project location, time, and date. And next, we are going to go back into our sun settings, And we're going to choose a single day, and also we're going to say from sunrise to sunset. All right, and we can choose whether we want to do summer or what. Let's do summer. There we go, sunrise to sunset. And the interval will be every hour. All right, so with that said, you can see it generated a sun path for us from sunrise to sunset, and we can see what every hour will be like. All right, now to generate our solar study, we're going to go to export, and then we're going to go to images and animations and go to solar study. And then we're going to generate all frames. That means all the different steps. We're going to include a timestamp, and then we're going to choose OK here. He's going to ask us to name our file, so we're going to call this solar study. What we want to do is where it says uncompress, we want to maybe compress it, so we're going to choose the Microsoft One video compressor, and we're going to choose OK. And there we go. That indeed did give us a very small file size, and that is what our solar study will look like.